Okay, so these notes are over graphing quadratic equations, and we're going to start off by graphing quadratics using a table. So, nope, that's an ad. Sorry, this is a new note-taking app, so I haven't worked out all the kinks yet. All right, so graphing a quadratic using a table, I already have the quadratic over here graphed to the right, but the way that we got that quadratic is by picking x values to plug into our equation to get the y values. So first off, we started with plugging in -3. So I would have, and this is kind of hard to write, so -3 squared plus 3 times -3 minus 1. So -3 squared is 9, plus 3 times -3 is -9, so 9 plus -9 is 0, minus 1 is -1. So we have a point at -3, -1, which is right there, like we already had plotted. And then we repeat the process over again with -2, so plugging in -2, -2 squared is 4, plus 3 times -2 is -6, minus 1. So we get 4 minus 6, -2, so -3. So we have a point at -2, -3. Plugging in -1, -1 squared is 1, plus 3 times -1 is -3, minus 1. That gives us also -3, so we have a point at -1, -3, which is right there. We already had that one. Plugging in 0, 0 squared is 0, plus 3 times 0 is 0, minus 1, so we have a point at -1, so 0, -1. And if we plug in +1, we have 1 squared is 1, plus 3 times 1 is 3, minus 1. So we get +3. So we have a point at 1, 3. So that's how we've generated this graph. So we simply plugged in x values to get the y values. All right, so if I have a choice of graphs in front of me and I want to know which one of these graphs is f of x equals 2x squared plus 3x plus 2, all I need to do is I need to pick an x value to plug in, and that corresponding point should match up with the graph. So first I'm just going to plug in 0. So plugging in 0, 0 squared is 0 times 2 is 0, plus 3 times 0 is 0, plus 2, so I have a point at 0, 2. So 0, I have 0, -2 here, so that's not right. I have 0, and that looks like 1 and some change, so that's not right. 0, 2 is right there, so this one's looking pretty promising. I'm still going to double check it with another point. And then this is 0, -1 and some change, so that's not right. So let's just pick one more point to confirm that C is the correct solution. So I'm going to plug in -1, and if I plug in -1 in for x, I should be getting a +1 out of this. So when I plug in -1, I have 2 times -1 squared is 1, plus 3 times -1 is -3, and then I have plus 2. Ran out of room. So 2 times 1 is 2, minus 3, plus 2, which would give me a +1. So I have a point at -1, 1, which we said we should have, so C is the correct answer. So I can pick x values, plug them in, and get points, and then just check my points against the graphs. Okay, so some parts of the graph of a quadratic that's really important. First up, the y-intercept is always the c. So our graph is always ax squared plus bx plus c. So c is always going to be your y-intercept, where you're crossing the y-axis. There's another really important piece of information called the axis of symmetry, and that's the equation x equals -b over 2a. So -b over 2a. We use -b over 2a to also find the x of our vertex. And we talked about that before when we were going from standard form to vertex form. So to find the x of our vertex, we're going to use that exact same equation, which is what's written right here. The x coordinate of the vertex is -b over 2a. All right, so the axis of symmetry is what cuts your parabola in half Okay, so anything happening on the left side is also happening on the right side. So your axis of symmetry has to go through your vertex. So that's why that equation define the axis of symmetry is the exact same as finding the x of your vertex, that hk that we talked about. Okay, axis of symmetry is also always written as an equation. It's x equals negative b over 2a. Okay, if you just say negative b over 2a, that's going to end up being a number, but that doesn't tell us the equation of the axis of symmetry. So it's always x equals. Don't forget that. Okay, so we're going to consider the quadratic function f of x equals 2 minus 4x plus x. We're going to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Now, we need to do some work to this equation before we can jump into doing all of that. And what we need to do is we need to rewrite our equation going in ax squared plus bx plus c format. So our equation is actually f of x equals x squared minus 4x plus 2. So there is our standard form. We can find the y-intercept really easy because it's always c. So our y-intercept is 0, 2. It's the point 0, 2. That is where we're crossing the y-axis. The equation for the axis of symmetry, that equation is x equals negative b over 2a. In this equation, b is negative 4. So the opposite of b would be a positive 4 over 2 times a is 1, which gives us 4 over 2, which gives us positive 2. So our axis of symmetry is y, I'm sorry, not y. Sorry, okay, it's x equals positive 2. And we can go one step further. We know the x-coordinate of the vertex already. It's 2. But we can go ahead and find the y of our vertex because we did this last week whenever we were going from standard form to vertex form. So we can find the y of our vertex, that k, by plugging in 2 into my standard form. So 2 squared minus 4 times 2 plus 2, which 2 squared is 4 minus 4 times 2 is 8 plus 2, which gives us a negative 2. So our vertex is at 2, negative 2. Our axis of symmetry is x equals 2, and our y-intercept is at 0, 2. Okay, so then we can figure out the graph of it by plugging in x values to get our y values. So if I plug in 0, we have 0 squared minus 4 times 0 is 0 plus 2. So we have that point at 0, 2 that we just got done talking about. Okay, if I plug in positive 1, I have 1 squared, which is 1, minus 4 times 1, which is 4, plus 2. So that gives me negative 3 plus 2, so negative 1. So that's the point 1, negative 1. When I plug in a positive 2, 2 squared is 4, minus 4 times 2 is minus 8, plus 2, so that gives me negative 2, so that's 2, negative 2, which was our vertex. When I plug in 3, 3 squared is 9, minus 4 times 3 is 12, plus 2, so we get negative 1. So we have a point at 3, negative 1. And plugging in 4, 4 squared is 16, minus 4 times 4 is 16, plus 2, so we have a point at 4, 2. Okay, so there's some of our points. So now we plot this graph. So those 5 points that we just found, we plotted. We knew that our axis of symmetry was x equals 2, so I always plot that with a dashed line. And anything happening on the left side has to identically happen on the right side. So the left side has to match the right, which this does. We did this correctly. Okay, it reflects perfectly across that axis of symmetry. We can also talk about the domain and range. So domain, it's going on and on and on forever to the left. There is no restriction to the smallest x value we can plug in. So we go from negative infinity, and then we're going on and on and on forever to the right as well. There's no restriction to how big of an x value we can plug into our equation. So we go to positive infinity. So our domain is negative infinity to positive infinity. Our range, and that's going to be the domain for every single quadratic. Our range is a little different though. You have to start from what's your smallest possible y value to what's your biggest possible y value you have. And we can look at the graph for this. So our smallest possible y value is right here. That's our minimum. And we have a point right there at 2, -2. So I'm going to do a bracket, -2. And then I go on and on forever going upwards. So I go from -2 to positive infinity. Okay, so I have the quadratic f of x equals 3 minus 6x plus x squared. So I'm going to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So first off, I'm going to put this in standard form. So f of x equals x squared minus 6x plus 3. So really quick and easy, I can find that the y-intercept... Oh my gosh, why is it not writing? There it goes. Y-intercept is at 0, 3. I like to write it as a point, but here it's written as just it equals 3. So we can get rid of b and d really quick because it's a positive 3 here. Now to find our axis of symmetry, it's x equals negative b over 2a. Well, b is -6, so opposite of b would be a positive 6 over 2 times a is 1. Which is 6 over 2. So x equals 3. So our axis of symmetry is x equals 3, which this one's -3, so that's not right. So it should be C. Our axis of symmetry is x equals 3, which means also the x-coordinate of our vertex is positive 3. And then if I wanted to go one step further, I could solve for the y of my vertex by plugging in positive 3 here and here. And then I would be able to crank out a y value for my vertex. Okay, this exact same quadratic, I can set up a table to solve for it as well, to be able to graph it. So let me rewrite this in standard form again. So f of x equals x squared minus 6x plus 3. So we already said we should have a point at 0, 3. So I can get rid of a because that's 0, -3, so that's not right. This is 0, -2, so that's not right. This is 0, 6, so that's not right. So actually only one of these answer choices is correct. But had we had more than one answer choice that had 0, 3 as a point, we can start by plugging in another x value. So I'm going to plug in 1 just to confirm. So 1 squared is 1. Minus 6 times 1 is 6, plus 3. So 1 minus 6 is -5, plus 3 is -2. So I have a point at 1, -2. Okay, so D is in fact the answer, but had we had two of these charts that had another point at 1, -2, then we would just move on to positive 2 and see which one's correct. So basically we're just using process of elimination. And lastly, we're picking out which graph is the correct graph given the points that we just found out. So we know we had a point at 0, 3. I remember that one. So we can get rid of B. And we can get rid of C because this is 0, -2. This is 0, -3. And this one doesn't have a point at 0, 3 because 1, 2, 3. 0, 3 should be right there. So it's not D. So it's definitely answer choice A. But then we can confirm with a couple of our other points we found. So here we had one at 1, -2. And here's 1, -2 right there. We have another at 2, -5. And here's 2, -5 right there. Okay, so we can confirm all of our other points with this graph and it's correct. Okay, talking about the minimum and maximum values, and I mentioned this just a second ago. Your graph either opens upward, which means your lead coefficient is a positive number. And when it opens upwards, that means that your y value is your minimum value. It doesn't get any lower